Critical angle, refraction of light, physics. Here we can see that two light rays, one traveling from water and passing into air, is bending away from the normal. And in the second picture we can see a light ray traveling from glass into air, which is also bending away from normal. So we knew that whenever light travels from a denser medium to a rarer medium, the light ray bends away from the normal. Here there are two ray diagrams of inaccurate values, only to make idea clear that whenever you increase the angle of refraction also increases. So in the first picture you can see a 20-degree angle of incidence in water is making a 40-degree angle of refraction in air, and when you change it to 45 degree as angle of incidence, the angle of refraction also increases. So, at a certain angle of incidence in denser medium, glass or water, the angle of refraction increases to 90 degrees. Means it becomes parallel, the refracted ray becomes parallel to the surface of separation of the two media. This special angle is given a name known as critical angle. Now we will understand the relation between critical angle and refractive index. We know that refractive index of air with respect to glass is sin I upon sin R. Sin I meaning the angle of incidence in glass, and sin R is the refracted angle of refraction in air. But when we talk about critical angle, the angle of incidence in the denser medium will be equal to the critical angle, and the refracting angle or angle of refraction will be equal to 90 degrees. Therefore, when we change these values, substitute these values, refractive index of air with respect to glass will be equal to sin C, C is critical angle, over sin 90 degrees. Although sin 90 degrees is equal to 1. Thus, refractive index of air with respect to glass will be equal to sin C, since sin 90 degree is 1, so sin C upon 1 will be equal to sin C. But we want the refractive index of glass, not of air. And refractive index of glass with respect to air will be equal to 1 over refractive index of air with respect to glass. If refractive index of glass is 3 upon 2, then refractive index of air with respect to glass will be the reciprocal of that, which will be equal to 2 upon 3. So, now refractive index of glass is equals to 1 upon sin C, since sin C was refractive index of air with respect to glass. Sin C is equal to 1 over refractive index of glass. Two important critical angles are of water, which is 49 degrees, and of glass is 42 degrees. Thank you, and please consider subscribing. Comment below if you liked the video.